Hey guys, this is the second logic game from the June 2013 LSAT PrepTest 69. This is the game involving 6 Petri dishes labeled 1 through 6. Now, this game is not an ordering game. The 6 Petri dishes are actually our variables themselves, and so I listed them at the top left here, 1 through 6, as well as 3 X's, because we're going to have a maximum of 3 dishes per shelf. So I've labeled here top, middle, and bottom shelves with 3 spaces each. The 3 X's will be our placeholders for the 3 spaces here that don't end up getting filled. Now I've laid out some other things here as well that I'm going to explain. They tell us that 2 is above 6, so I've laid out 2-6 here, 2 coming higher up than 6, given our top, middle, bottom orientation here. They tell us that also, based on that, then that 6 cannot be on the top and 2 cannot be on the bottom. They tell us that 5 and 6 have to be on shelves that touch, could be in either order. And they tell us that 1 and 4 cannot be on the same shelf. So I've mapped that restriction as well, saying they cannot go together horizontally. Of course, left and right orientation doesn't matter here. So this game is actually what I would call a matching game, since we're simply placing them and associating them with top, middle, bottom shelves, but what happens with regard to order on each shelf is not even covered by this game. So this here is a pretty bare bones simple diagram for the game. It's perfectly sufficient for you to take this and move on to the questions themselves. However, I like to do a bit more here. Based on the fact that 2 has to go above 6, we can actually start off by making 3 different main diagrams here, based on whether we have 2, 6 on top, middle, 2, 6 on middle, bottom, or 2, 6 on top, bottom with a space in between it. Any of those 3 is fine, so I'm going to lay those out now as well. So here are those 3 diagrams that result, and now we can also add in some additional information regarding the placement of 5, since we know that 5 and 6 have to be on shelves that touch. For the top possibility here, we get a 5 on top or bottom, so I'm actually going to split that into 2 different possibilities as well in a moment. But first I'll tell you simply that for this other possibility here in the middle, 5 has to go on the middle shelf, since it can't go below bottom since there is no such thing. For this bottom possibility as well, 5 has to go on the middle shelf. So here we could have 5 on top here or on bottom here. Either way, it doesn't really matter. I'll split this into 2 possibilities now to show you. So here we go. Here are the 4 possibilities for the game. These 4 possibilities cover every single valid scenario that could result from all the rules and gives you a good starting point to go in and answer the questions, making them even a little bit easier than they already were. Again, of course, you don't have to do these multiple main diagrams. You could have stuck with the bare bones diagram and then just used the rules a little bit more over the course of the game, but I do think this makes things a bit easier. Now we have remaining simply that 1 and 4 can't be together, and then the variable number 3 is simply a floating variable with no restrictions on it at all. So this is a good position from which to go in and attack the questions. So let's start with question number 6, which is a general orientation question. Now you'll see, of course, that LSAT tried to mess with us a bit by presenting the information here backwards from what I've done and from what most of you have likely done. They listed things going bottom, middle, top, rather than top, middle, bottom. So requires a little bit of reorientation if you do things this way, as I've done with top, middle, bottom, from going high to low. I recommend still doing it my way, even though LSAT does it the other way for number 6, because I believe it's a more natural way for most of us to approach this, and I think you'll find that it actually isn't that bad to reorient yourself to their way simply for number 6, and then go back to my way and what's probably your way as well, going forward to the rest of the questions. So anyway, number 6, general orientation question. We simply take 1 rule at a time and apply that rule to all 5 choices, checking for violations. So starting off, maximum of 3 spaces per shelf. Choice A violates this, having 4 of them on the top, so A is gone. We know that 2 is above 6. Choice C violates this, having 6 on middle, 2 on bottom, so C is gone. Next we have 5 and 6 have to be on shelves that touch. Choice E violates this, having 5 and 6 spread across top and bottom. We also know that 1 and 4 can't be on the same shelf. And choice D violates this, having both of them together on top, leaving B as our answer for number 6. Next, number 7, if dish 6 were the only dish stored on the bottom shelf. So right away, the top two possibilities here are irrelevant since they have 6 on the middle shelf, not the bottom shelf. Then additionally, of course, 6 is the only dish on bottom, so 2 of our x's, our placeholder variables, will have to go on the bottom shelf to remind us of this limitation. Then we have, the split between 1 and 4, they have to be separated, so one of them will go on top, one of them will go on bottom for each of these 2 remaining diagrams, and then we have the variable number 3 remaining, which on the top possibility will go on top shelf as well as another x. 3 and x will alternate on the remaining possibility here on bottom. So they're asking us simply what could be together on the middle. We see from our top possibility here 3 variables listed, 2, 5, and then either 1 or 4. But our answer choices for number 7 list only 2 variables. So for that reason, this diagram isn't going to be useful. We have to use the bottom diagram that I've drawn here. And again, since we have only 2 variables listed, we're going to want to put 3 on the top shelf and x on the middle, leaving either 1, 5 or 4, 5 on the middle shelf to evaluate the choices with here. And we see that choice E lists 4 and 5, so E is our answer to number 7. Next, number 8, if dishes 1, 2, and 3 were on the same shelves as each other. So right away, the possibilities that have 2 with something else like 5 are completely eliminated from relevance here. We want to use only the diagrams that have 2 with nothing else at the moment, so we can add in 1 and 3. Then the only variable we have remaining right now is variable number 4, so we're going to have 4 on either the middle or bottom shelf. In both of these remaining possibilities, 4 will be alternating with the remaining placeholder x. So they're asking us what could be true. Exactly 1 dish on top. No, we have 3 dishes, 2, 1, and 3 all appearing on top. 2 dishes on top. No, again, we have 3 dishes there. 2 dishes on the middle works fine. We could have 4 with 6 or 4 with 5, and nothing else would be with those 2. So C is our answer for number 8. I will look at D and E though. 3 dishes on the middle. No, we have 2. 3 on the bottom. No, once again, we have 2. So C is our answer for number 8 by elimination if you didn't get it before. Next, number 9, if exactly 1 shelf had no dish on it. So the possibilities that have 2, 5, and 6 spread across the 3 shelves are irrelevant. We're left with only the other 2 possibilities. 1 shelf with no dish at all, so on one of these possibilities it'll be the bottom shelf with nothing, the 3 placeholder x's. In the other possibility it'll be the top shelf with nothing on it at all. Then we have 1 and 4 alternating on the remaining shelves, as well as the variable 3 going wherever is left. So we have 1 and 4 alternating once again, and then variable number 3 remaining in the last space we put down. So they're asking us what must be true. 3 dishes on bottom. No, we could have no dishes on bottom, so A is gone. 3 dishes on the middle occurs in both of these. So for that reason, B is our answer to number 9. I will look at the remaining choices though. 1 and 5 on the same shelf. That could happen in either of these, but does not have to. So C is gone. 2 and 3 together cannot happen in either of these, so D is gone. And then choice E, 4 and 5 on the same shelf, does not need to happen because 4 and 1 are interchangeable, leaving B as our answer for number 9. Next, number 10, if 5 were the only dish on bottom, so right away, anything where 5 is on the middle or top is gone. We're left with only this possibility here, 2, 6, 5 on top, middle, bottom, and since 5 is the only dish there, I'm going to put x's on the 2 remaining spaces on bottom. Then they say 2 dishes on the middle means it's going to be 6 and then 1 other thing. So we have 1 and 4 interchangeable on top and middle, leaving 3 to go on top. So now they ask us, what is a pair of dishes that must be among those on top? Well, 2 and 3 have to be there, so C is our answer to 10. It's either 1 or 4 on the top, not both, so neither 1 nor 4 in particular needs to be there. 1 and 4 simply are variables that could be there. So C is our answer to 10. Finally, number 11, if exactly one dish were stored on the middle shelf. So right away, the choice mentioning 2 and 5 on middle is irrelevant because it has 2 things there, not only 1. Then for the remaining choices here, we're going to have to limit things by putting down restrictions on the remaining middle spaces because we're going to have only either 5 or 6 on middle spaces. Then we have the variables 1 and 4 remaining, and they are interchangeable in our remaining spaces here on top and bottom with no difference between them at all really. Then we simply have the variable 3 and the placeholder x left to deal with. Things are pretty open-ended on 2 of these remaining 3 scenarios, but on the upper left one here, we're definitely going to have 3 and the placeholder x. So that one fills in pretty nicely. They're asking us what could be dishes on the top shelf. The top left possibility here isn't going to be useful because it lists 3 variables, not 2, and all of our choices here mention only 2 as being the list of variables. So we're not going to use this upper left one, we're using only the upper right possibility and the bottom left possibility here. And they're saying only 2 variables for each one, so I'm going to put a placeholder x in the remaining top shelf space, leaving the variable number 3 to go on the remaining spaces that are empty. So we have here 1, 2, or 2, 4 as our remaining possibilities for what could happen on the top shelf. 2, 4 is not a choice, but 1, 2 is choice A, so A is our answer for number 11.